continuation of the previous video on arithmetic progressions, wherein in the previous video we had learned to find the general term, and we found the general term from the n. In today's video we will be learning to calculate the sum of n terms of an AP. We will be also learning the relationship between the sum of n terms of an AP as well as the nth term. To begin with, let us consider an AP of n terms. Standard AP is given as A plus D, A plus 2D, and so on, with the last term included, where L is the last term and Sn, let Sn be the sum and L be the last term. Now since L is the last term here and this is a finite series or finite sequence, L in this is nothing but the nth term. And the nth term for the AP is given as A plus n minus 1 times D. Let us take this as equation 1. Now since Sn is the sum of these n terms of an AP, so therefore Sn will be given as A plus D plus A plus 2D and so on till L minus D, one term previous to it, plus the last term. Let us take this as equation 2. Next thing is, in the next step we will reverse the right hand side terms, that is the last term we will write it as the first term. So reversing only the RHS, that is the right hand side terms, we get Sn is equal to L plus L minus D, so on till A plus D plus A. Let us consider this to be as equation 3. In the next step we will add equation 2 and equation 3. So what will you get is 2Sn, this is adding 2 and 3. I get A plus L. In the next case as well, we see that plus D and negative D will cancel to give you again A plus L, and so on. This will repeat for n terms. So we see over here that A plus L, this bracket, is been added n times. And we know that, say suppose if you have 8 which is added 4 times, then in the shortest way I can write it as 4 into 8, which will be 32. In the similar way, A plus L is repeated n times or added n times, so this will be n into A plus L. Therefore Sn is equal to, getting 2 down, I have n divided by 2, A plus L. This is the sum of n terms for a finite sequence when the last term is given. Now if suppose we have to find it for an infinite one, so in that case, in this equation we substitute the first one, that is L. So that will be Sn is equal to n upon 2 A plus, instead of L we will write it as A plus n minus 1 times D. What do you get? We get n upon 2, 2A plus n minus 1 times D. And this is the second equation. In order, whenever you're solving problems for sum, you can use any one of these formulas. Even for finite series, you can use this finite sequence, you can use the same formula, this one, any one. But this formula is compulsorily used only when there is a last term. If the last term is given, you can still use this formula, where A is the first term, N is the number of term, and D is the common difference. And here L is the last term. To understand the relation between the sum of n terms of an AP and its nth term, we have the formula Sn as n upon 2, 2A plus n minus 1 times D. Take the sum of n minus 1 terms, so you replace in this formula n by n minus 1. So in this case also n will be replaced by n minus 1 to give you n minus 1 divided by 2, 2a plus n minus 2 times d. Now let us take the difference. Note that Sn will be greater than Sn minus 1. So when you take the difference, I write the formulas as it is, and then in the next step I have multiplied them inside. So when I have multiplied inside, the 2 cancels here, and in this case I have multiplied 2a with n minus 1 together separately. So it is 2a into n divided by 2 will be na, and the next one will be plus a plus 2a divided by 2 will give you a, and this one as it is. So we see that an and negative an will cancel, and you have a plus. From these two I will take n minus 1 times d divided by 2 common. So I have n, and from here I will have n minus 2. So when I multiply the negative sign inside, I have plus 2. The negative n and the positive n cancels to give you a plus n minus 1 times d into 2 divided by 2. So this is nothing but the formula for nth term. So you have an, which is Sn minus Sn minus 1. Which means that, say, if you have the sum of the first 4 terms and you subtract it with the sum of the first 3 terms, this subtraction will be nothing but the 4th term. So this formula you can use when you are given the sum of, say, n and the sum of n minus 1 terms to calculate the nth term. Let us now take some problems from exercise and solve some problems. Let us consider the first problem from exercise 10b. Note that this is an infinite sequence, so we will be using this formula. We cannot use this one because the last term is not mentioned here. So what you require is n, a and d. So a is the first term, which is nothing but 2. D is the second term minus the first term, which is nothing but 5. And here n is up to 19 terms, meaning n is equal to 19. So to calculate the sum, it will be S19 will be equal to, we will be using this formula. So you directly substitute. So this will be 19 divided by 2, 2 into 2 plus 19 minus 1 times d, that is 5. So this will be 19 divided by 2, you have 4 plus 18 into 5. 19 divided by 2, 4 plus 90, and this will be 19 divided by 2 multiplied by 94, which when you cancel you'll get 47, which is equal to 893. That's it. Let us consider another problem, problem number 8 from the same exercise. You have to find the sum of this sequence. Note that here the last term is mentioned, but what is not mentioned is the number of terms. So let us write what is given. A is negative 5, D is negative 8, negative of negative 5, which is nothing but negative 8 plus 5, which is equal to negative 3. You are given the last term, which is minus 62. Now you have to calculate n here first to calculate Sn. Now, how will you find n? We know that this last term in a finite sequence is nothing but the nth term. So using the nth term formula for an arithmetic progression, which we had covered in the previous video, we have an is equal to a plus n minus 1 times d. Using this formula, we will be calculating n. So an is negative 62 is equal to a is negative 5 plus n minus 1 as it is, and in place of d I will be taking negative 3. Please make use of brackets here. So taking the negative 5 on the other side, so it will be positive 5 to give you 57 is equal to n minus 1 times negative 3. Dividing, since this is multiplication, so you divide this. So I have n minus 1 will be equal to negative 57 divided by negative 3. So this cancels and this is 19. Therefore n is equal to 19 plus 1, which is equal to 20. So now we have calculated n. The next step is to calculate the sum of these 20 terms. So sum of the 20 terms, you can use either this formula or this one. But since the last term is given, I prefer the second one. So that is 20 divided by 2. I have a is nothing but negative 5 plus the last term is negative 62. This will be 10, negative 5, negative 62, 10 into negative 67, and you have negative 670 as the sum of 20 terms. Let's consider another problem, problem number 9. You have to find the sum of all 2-digit natural numbers which are divisible by 5. Notice in this problem, you are not given the sequence, but there are two conditions mentioned, that it is a 2-digit natural number and it is divisible by 5. Now, let us first write the sequence. Which is the first 2-digit natural number? The first 2-digit natural number is 10. Let us see if the second condition is also satisfying. That is it divisible by 5? Yes. Let us go to the next 2-digit natural number which is divisible by 5. It is obviously 15. And then there is 20 and so on. Now do we know the last 2-digit number which is divisible by 5? Yes, it is 95. And that's it. After that are the 3-digit numbers. So once you have written the sequence, we see that here again, this is a finite sequence wherein the last term is given. So you have a, that is 10, the first term. The difference is second term minus the first term, which is equal to 5. And the last term is 95. Now in order to find the sum, that is we have to calculate Sn. What do we require? N. So you require N. This is same as the previous problem that we have done. So you can pause the video, do it yourself and then check if it's the correct answer. So here taking the last term as the nth term formula, you calculate n. Please go through the steps properly and see if you have got it correctly. And then once you have got n equal to 18, therefore I find the sum of 18 terms. Using the same second formula, you can use the first one, you will still get the same answer. So this is 10 plus 95 and this is the answer. You have problem number 15. The sum of the first 3 terms of an AP is 42 and the product of the first and the third term is 52. You have to find the first term and the common difference. So since it is required to find the sum of the first 3 terms, so let us assume that the first 3 terms, let the 3 terms of an AP be A plus D and A plus 2D. You can also take A minus D, A and A plus D as we had done in the previous video of the nth term. So the first condition says that the sum of the first 3 terms is 42. So adding this, what you get is 42. So adding, there are 3 A terms and 2D plus D will give you 3D. So it is 3A plus 3D is equal to 42, which is A plus D, which is equal to 14. Therefore, A will be equal to 14 minus D. Let this be equation 1. The second condition states that the product of the first and the third term is 52. The product of only the first and the third term. So what do I get? A into A plus 2D is equal to 52. Substituting 1 in this, so I have 14 minus D. This is 14 minus D plus 2D is equal to 52. So I have 14 minus D and 14 plus D, which is equal to 52. This is A minus D, A minus B, A plus B, which is equal to A square minus B square. So this will be 14 square minus D square is equal to 52, which I get as 196 minus D square is equal to 52. Therefore D square is 196 minus 52, which is 144, and hence D is equal to two values, that is plus or minus 12. You have to find the first term and the common difference. So the first term, now here, since the difference is giving two values, one is positive, one is negative, so there will be two cases. That is, when D is equal to 12, A will be equal to 14 minus D. 14 minus D is 2. So when D is positive 12, A will be 2. That is the first term. And when D is equal to negative 12, A will be 14 minus of minus 12, which is equal to 26. The same thing you can do it with this formula as well, using these terms. Now when you are taking these terms again, the sum of all of this is equal to 42. So when D will cancel and you will get directly A is equal to 14. Now note that this is not the first term. If you are taking these terms, A minus D is the first term here. Then the next thing says that the difference, the product between the first and the third term is 52. So which will be A minus D, and A plus D is equal to 52, which is nothing but 14 square minus D square. A is 14, so it will again come up to the same thing. So therefore D will be equal to plus or minus 12. So when again D is equal to positive 12, your first term is A minus D, so which will be 14 minus 12, which is 2. And similarly, when D is equal to negative 12, you will get the first term is, or A1 to be is 14 plus 12, which is equal to 26. If you are taking these terms, please do not make the mistake of taking A as the first term. Let us consider the 18th problem, which is a word problem. Read the question carefully. You will understand that out of this 200 logs, 20 logs are placed in the bottom row. Okay. Then there are 19 in the second last, then this in the third last, and so on. So the sequence begins from 20 here. So we see that this is a decreasing sequence. So here the AP will be 20, 19, 18, and so on. How do we know this is an AP? Because the common difference is the same, that is negative 1. Now 200 logs, meaning in total all these logs which are placed in the rows are 200, which means that Sn is equal to 200. Now we have to calculate how many rows are formed. These lines are the rows, meaning if we have to calculate how many numbers are there, okay, how many terms are there which are arranged in such a way. So we have to calculate what is n, and we have to calculate how many logs are there in the top row, meaning the last one according to this sequence. The last one, if we consider, so till the last one, whichever how many logs would be there in that would be a finite sequence. So that is nothing but the nth term is what we are supposed to calculate. Once you calculate the number of terms, we are told which number is present in that nth position, which is nothing but the nth term. What is given? You know that the first term is 20. You also know that the difference is 19 minus 20, which is negative 1. So now to calculate n, we require, in the previous problem we took the nth term. So in this, how would we do it? Is by taking the sum of n terms formula. So that is given by this one. Cannot take this one because we do not know the last term. So Sn is equal to n upon 2, 2a plus n minus 1 times d. Sn is nothing but 200. N we do not know, so we leave it as it is. 2a, a is 20, multiplied by 2 is 40, plus n minus 1 times negative 1. Now cross multiplying this, I'll do it here, 400 is equal to n into, this is 40 plus, this will be minus 1 into minus 1 will be 1, and minus 1 into plus n will be negative n. So opening up the brackets over there, I have 400 is equal to 41n minus n square. Taking on the other side, I have n square minus 41n plus 400 is equal to 0. Now this is a quadratic equation, so it means we have to find the factors of 400, which when you add, I have to get 41. Those factors are none other than 16n and 25n. Okay. So therefore I will have n minus 16 and n minus 25, which is equal to 0. This, when there is a positive sign here, this negative sign goes to both the factors. I have skipped one step and I have directly written the final one. So therefore here n is equal to 16 or n is equal to 25. So it means there are either 16 rows or there are 25 rows. Now to check which one is the correct one, let us find the nth term using both. Let us take, say, A16. Let us check how many logs are there in the 16th row. So that will be given by A plus 16 minus 1 times D, where A is 20 and this will be 15 times minus 1, which will be 20 minus 15, that is equal to 5, which is working out. So it means there are 5 logs in the 16th row. The next one is when your n is equal to 25. So you have A25 will be equal to 20 plus 25 minus 1 times negative 1, which will be 20 minus 24, which is equal to negative 4. Now, there cannot be negative 4 logs in the 25th row. So it means this term is discarded. So therefore, there are 16 rows and 5 logs in the 16th row. That's it. In the next problem, we will be using this formula. It is given that if Sn, the sum of the first n terms of an AP, is given by this, meaning Sn is equal to 5n square plus 3n, we have to find its nth term. Now to calculate the nth term, let us find first what is Sn minus 1. Sn minus 1 will be replacing in this expression in place of n by n minus 1. So I have 5 n minus 1 plus 3 times n minus 1. Opening up the brackets, I have n square plus 1 minus 2n plus 3n minus 3, which is 5n square plus 5 minus 10n plus 3n minus 3. So I have 5n and this will be plus 2, this will be minus 10. 5n square, this will be negative 7n plus 2. So now using this formula, which is Sn minus 1, which is equal to the nth term, I'll be substituting these values. 5n square plus 3n minus 5n square minus 7n plus 2. Opening up the brackets, this term will cancel and you will be left with 3n minus of minus 7n will be 10n, and that will be negative 2. Therefore, the nth term is given by 10n minus 2. If you had to calculate, if from here if they had to tell you to find, say, the 6th term, then you would just replace in this expression now, wherever there is n, you would replace it by 6 and do it. On today's video, that is to calculate the sum of n terms, try solving exercise 10B from R.S. Agarwal and solve one of this problem. Thank you.